Okay, so I'm going to try to take a look at the pen tip, just because it's a revolve and that's been tricky for people in the past. So I want to make a vertical line. I made a new drawing. This is a new part drawing. This is a new sketch. The way I'm going to approach this is I'm going to kind of use Inventor to do the math for me. I want to figure out kind of a half profile for this. So the way I'll do this is, and I'll show this on the first thing, if I figure out the outside diameter of this thing is 0.135, and then I put that in going this way, so it's straight over, so 0.135, but it's half that, so I'll put divided by 2, because that's how far it's sticking out from the middle. And I don't know exactly where the middle is, and I don't want to try to measure from the middle, because that would just be me eyeballing an approximation for the middle. So now what I'm going to do to get the taper is I'll measure to the top of the taper right before it gets a little bigger, 0.315. So it's going to be 0.315, but that 0.315, which is going to be divided by 2, is going to be how far from the bottom? 0.702. So I'm going to go up, because it was vertical, 702. So that's where I'm going to come out from. So I need to go over to here, and I'm going to go out half the distance that I had, which was 0.3, or that's 0.296. So it's 0.296 divided by 2. And then that goes down to there. So I'm just going to escape. You could drag dimensions out of the way because they're going to be in the way of the C. Alright, that line doesn't matter anymore. I was just using that for spacing. So this is the taper to just the bottom of, there's sort of a bald edge here that gets a little bit bigger. So then that additional size taper I'll go for here, starts right at the end of that, and it is 0.325 divided by 2. Line from the same point, it just was like right past it. 0.325 divided by 2. So very small difference, but it's big enough that I want to be able to see it. And now that goes up from there. So I can't see the line for the one, so it's 0.83. So it's going to go up 0.83. Another way I can do these lines is just from right here. So 0.83, sorry. And then it goes over, because this is the top of this full ridge now, 0.335 divided by 2. 0.335 divided by 2. And then that'll go to where that's stuck out there. I'm just using the scroll wheel to magnify myself in and out. Right click, okay. Let's move the dimensions out of the way for myself here. Alright, so that's the taper to the tip, that's the little ridge. Alright, so now I'm right under it. I'm at the part where it gets into the fitting bit. And that part starts at 0.25 divided by 2. So that came in. Now there's other ridges in it, which, because this doesn't really fit in, I might ignore for this exercise. Let's just see how it is on the very bottom there. I might simplify this part. So that was 0.25. This is 0.24 at the very, very bottom. So I'll keep that taper on it. I just don't want to oversimplify and lose a lot of my detail. Alright, so now this is going to go down 0.167. So I can do another line from here, 0.167. And then I'm going to go out. It was 0.24 divided by 2. And if you already had a line there, if you move, it should snap to it. So I can snap to it. I can see it's right there, that green dot. And I'll snap to that. So that snapping point is the spot for where it kind of ends that section. All right. So I've got this. Now this is going to come out to be a solid. So now I got to kind of do some figuring, because we've got kind of a hollow tube, although it does get a little thicker down at the bottom. I can use my depth gauge to sort of figure out. Oh no, I can't, because it doesn't fit all the way in. So this is a good application for shell, which inside it looks like it might be shelled. It's kind of hard to see for me. But we can use shell. Now the important thing that we do need to have to match our stuff, though, is this shell thickness. We can measure, it's the thickness of the actual part, is 0.19. So I'm getting ahead of myself. So 0.19 or 0.019 is the thickness of the shell, but I got to revolve this first. So you can click on multiple bodies, multiple parts, and I'm going to select the axis. I'm going to select that line. It'll spin that around. I can say OK, so that does look like my pen part. I'm going to use shell to kind of cheat this, so that's up here under modify. So my thickness that I would like this to be is 0.0, bumped up to 2. So 0.02 should be fine. And I want it to remove face. I want to do that. So it's going to be the hole there. So that should hollow out the whole pen when I say OK. So I can see all the way to the bottom. And I left that bottom bit there because I actually can go in with the width measurement on the other side and get the width of that opening. So the width of that opening for me here is 0.065. So that I can do as a negative extrusion on that face. The nice thing about having a previous circle there is if I hover, it should snap to the middle. And the diameter I said was 0.065. So that diameter, finish sketch, that is in the middle of my circle. Whoops, scroll wheel. I'm going to extrude it, but I'm going to cut extrude it the other way. So that is the pen tip as I have it in front of me. If you want to round out edges, for example, it does kind of round there at the end. You can play with things like the fillet. Just right there, you're just going to have to keep the radius really small. And I'll let you play with that if you decide to use it. So I can try to get it as small as possible. Maybe move it to 0.005. So that bit's kind of extra. It's just going to give it more of a matching look to the part that we have. But that's just kind of a walkthrough and approach on how to do it. Again, the basis for how I'm approaching it is I'm measuring the full width, I'm dividing it by 2, and I'm using that to make kind of that half profile that I revolved. So if you have any questions, let me know, but that's kind of that is my approach to doing the pen tip.